Hey guys, Brendan Productions here, and welcome to the fourth video of the Python tutorial series. In this video, we're going to be talking about function typecasting and Booleans. So our first point of discussion is typecasting. Now, let's go ahead and open up the Python REPL. So in the past tutorials, we've covered a few types, right? So let's go ahead and list them out here. We've got a string, hello world, right? We've got an integer, a float, a list, a tuple, and a dictionary. So all of these types have kind of different semantics, right? Each one operates differently. Each one has different arithmetic overloads. However, some of these types can be converted or cast between one another, right? And the way this is done is through functions. And these functions come shipped with a standard Python distribution, and they're named after the types themselves. Now, these are actually class constructors, these functions, but we'll just call them functions for now. So, take a string, for instance. So if we type hello world, whoops, we're just getting the type of a string here. We can see that there is a class string. However, if we type string of hello world, we can see that it is essentially the same thing, right, as just typing the string itself. And this is because we're actually invoking the class constructor for the string type. Now we're going to be discussing classes in a much later tutorial, but right now just know that this is a function that can be called to convert one type to a string. So if we actually type str of 5, what do you think is going to happen? Right, so this constructs a new string with the parameter of 5. And remember, 5 is an integer, but if we do this, it automatically converts the 5 to a string. You can tell it's a string because it has the quotations around it. Now what happens if we do the same thing with a float? The same thing. The thing with a list, it turns the list into a string. How about with a tuple? Same thing. Or a dictionary. Same thing. So this class constructor converts the types into a string, right? You can see this even further if we populate the dictionary. Let's say d equals, we'll use the classic hello world dictionary that we've been using throughout. If we type strd, right, we get this nice string representation of the dictionary. Now notice the entire string is in double quotes, and then because each key and value is also a string, they are in single quotes, because if they were in double quotes here, they would have to be, or since the string is in double quotes, the key and value in double quotes would mean that the string would end here and start again here and end here and start again there. So Python's smart and puts them in single quotes because they're inside of double quotes. So just like the class string, right, there is also this conversion semantic for ints, floats, lists, tuples, and dicts. So if we have a string 5, let's say s equals 5, right? So s is a string. What happens if we do int of s? Well, as you might expect, since the string is just the string representation of the number 5, int of s is able to convert it to an integer no problem, right? If we do type of int of s, oops, missed a parenthesis, we get that the class is int. But what if s is a mixed thing, right? 5a, and then we do int of s. The type conversion is smart enough to know that you can't convert 5a into an integer. Of course, it says invalid literal for int with base 10, because 5a could actually be a hexadecimal number, but it's assuming base 10 here. So, unfortunately, int it has some limitations. It's not as flexible as string, right? Like if we try to take int of an empty dictionary, we can't do it. Or int of a tuple, right? We simply cannot do it. because that doesn't make sense. How would you convert that into an integer? But we can do it with string. Same thing with float. If we have s equals the string 5.5, we can convert s to a float, right? Type of float of s, it's a float. But we cannot convert a dict to a float. So there's some flexibility. Now, what happens for list, right? So the type of an empty list is list. So you would think that we can use this constructor to create a list from items. And let's try. If we have an s, a string, hello, and we create a list from s, you can see that some interesting behavior actually happens. It actually takes the letters of the string and separates them into separate characters inside of the list. So basically the list constructor takes any sequence and breaks the sequence into its individual parts. Now how about list of an integer? So it tells us that the int object is not iterable. And this is just because, right, an int is not a sequence, so it can't break it into its parts. Same thing with a float. You can't break a float into its parts. However, you can break a tuple into its parts, right? Because a tuple is essentially a list with some limitations. Now, how about a dictionary? We have a dictionary, hello world, D, right? What if we could turn D into a list? Oh, it looks like it just takes the keys of the dictionary. We can confirm this. Hello world. Actually, we can update. Goodbye moon. So D now has two keys. If we turn D into a list, you can see that it actually just creates a list with the two keys. Now, the same type conversion can happen with a dict. What happens if we take a list? Let's create a new list called L. Right? And what happens if we turn L into a dict? Looks like it's not able to do that because this semantic is actually a little tricky. It says dictionary update sequence element number 0 has length 5, 2 is required. So what happens if we meet that criteria? What if L is a list of tuples? Hello, world, and the second tuple is goodbye, moon. All right, if we turn this into a dict, you can see that it actually takes the first element of each tuple and turns it into the key. So it's kind of an undoing of the list of dict semantic. And the tuple works just the same as the list, right? So if we take S, our string, and turn that into a tuple, it creates a tuple and breaks up the characters. So there is this class constructor type conversion semantic. So why am I talking so much about this? Well, this is actually insanely important when we get to the Boolean type. So what is a Boolean type? A Boolean is something that can either be true or false. So if you just type true with a capital T into Python, you'll notice that there's no error because this is actually the Boolean type true. Same thing with false with a capital F. And if you actually get the type of true, you'll see that it is a bool, short for Boolean. So Booleans are how Python decides whether or not to execute something. You can say if this or that, while this, do that, and such things. So, for instance, we can say 1 equals 1, right? So equals is a comparison operator. So does 1 equal 1? We get the Boolean value true. Is 1 greater than 1? False. Is 1 less than 1? False. Is 1 greater than or equal to 1? Yes. Yes, it is. So this is playing with Booleans. So Booleans are a class, right? Just like lists are a class. So they probably follow the same exact type conversion semantics. And you're right, they do. So if we have a string s, which is hello, we've been using, what happens if we convert that to a bool? Remember that bool is true or false. So what do you think would result if we try to convert this string to a bool? You might think, well, is the string itself the word true? That would be a good guess. Somebody else might think, oh, is the string empty or not? Like, does the string actually contain contents? Okay, maybe. Somebody might think, oh, is the string, does it have a number that's greater than 0 inside of it? You know, the possibilities are large, and it's not as clear-cut as our other type conversions. But let's go ahead and see what happens. You can see that it is true. How about our list, L? What happens when we convert L to a bool? It's true. Our dictionary D? It is true. So, there's this interesting assumption that Python makes, where these certain base types that we've been talking about, they have particular properties that might make them true or false. Now, let's go ahead and set S to the empty string, right? Might have been what some of you were thinking. And what happens if we get the Boolean value of S now? Ah, now it is false. Right? What happens if we get the Boolean value of 5? It's true. What happens if we get the Boolean value of 0? False. 0.0? False. Right? You might see where we're going with this. The bool of the empty list? False. Empty tuple? False. Empty dictionary? False. So, for all of these standard Python types, right, for the numbers, the Boolean is true if the number is not 0. But if the number is 0, it's false. The Boolean of a float is false if it's 0. The Boolean of a list is false if it's empty, true if it contains contents. A tuple, false if it is empty, true if it contains contents. Same with a dictionary. False if it's empty, true if it contains contents. So this actually allows for some interesting flexibility, right? So you can start comparing things based on these Booleans, right? So this allows for some interesting flexibility. In our next tutorial, we'll be talking about if statements and general control flow of our programs. We'll also get out of the REPL a little bit and start writing some actual Python code. And this Boolean magic is going to be very useful for us. So stay tuned for that. Anyway, thanks a lot for watching this tutorial. Hope you learned something from it. Remember, if you have any questions, feel free to ask in the comments below, and I'll get to them. Have a good day, and thanks for watching. Bye-bye.